Alrighty, number 3, the function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. Part A asks us to find the value of f of -6 and f of 5. So I'm going to start off with f of -6. Alright, so I notice they give me one x value. We are looking for the value at another x value. So as long as they do that, we're pretty much going to be using the fundamental theorem of calculus. So if you recall the fundamental theorem of calculus, it's something like from f prime from a to b is going to equal f of b minus f of a. So that's the formula I'm going to be using. So if I'm looking at an x value of -2 and -6, I'm going to go from -6 to -2 of f prime. Notice this is f prime. When we take the integral of f prime, I'm just left with f, so I'll do f of -2 minus f of -6. Then from here, to find the integral of f prime, the integral is the area under the curve. We're going to be going from -6 to -2, which is going to be this triangle right here. So to get this value, it's going to be 1/2 times the base, which is 4, times the height, which is 2. That is going to give me an answer of 4. So I'm going to get 4 equals f of -2, which they told me was 7, minus f of -6. And when I do that, to solve for this, I would subtract 7 from both sides. So I'm going to get -3 equals negative f of -6. And then I'll divide both sides by -1. I'm going to get f of -6 is equal to 3. I'm going to do that same thing for f of 5. So this time my x values will be -2 and 5. So I'm going to have the integral from -2 to 5 of f prime will equal f of 5 minus f of -2. Okay, so then from here, to find the integral of f prime, we'll find the area under the curve from -2 all the way to 5. So we're going to find these two areas. Well, I notice this first area is negative because it's below the x-axis, so it's going to be -1/2. And it's a half circle, so it's going to be 1/2 pi r squared. The radius is 2, so it's going to be -1/2 pi times 2 squared plus this triangle. This triangle is going to be 1/2 times the base, looks like it's 3, and the height is 2. So this will be -2 pi plus 3. And then it will equal, I don't know f of 5, but I do know that f of -2 is 7. So now solving for f of 5, I'll just add 7 to both sides. So I'll get -2 pi plus 10 is equal to f of 5. And so if I used this condition that f of -2 equals 7 somewhere in my problem, I'm going to get a point. If I correctly found that f of -6 was 3, I'm going to get a point. If I correctly found that f of 5 was equal to -2 pi plus 10, I'd get a third point. Okay, part B, on what intervals is f increasing? So we need to, if I want to know where f is increasing, I need to make an f prime chart. And if this is f prime, I will be looking above and below. So if I make my f prime chart, we are above the x-axis until -2. I am below the x-axis until 2, and I'm above the x-axis after that. So if I'm looking for where am I increasing, it would be here and here. It looks like this starts at -6, so we're going to be increasing -6 till I get to -2. And then again, I'm increasing from 2 till I get to the endpoint of my interval. And it said to justify my answer, that's going to be because f prime is positive. All right, part C. Find the absolute minimum of f on the closed interval -6 to 5. So if I want to find an absolute minimum, I want to find my critical values, and I want to find what's happening at my endpoints. So we are going to, my critical numbers, if I looked at my f prime chart, I believed I had -2 and 2 on there, so those are my critical numbers. So I would like to find f of -2, f of 2, f of -6, and f of 5. All right, so if I find those, f of -2 is actually given to me, it was 7. F of -6 we already found in part A was 3. F of 5 we already found in part A was -2 pi plus 10. And f of 2, I suppose I could find that one. Let's do that same thing that we were doing before. -2 to 2 of f prime is equal to f of 2 minus f of -2. this would be the area under the curve from negative 2 to 2, so it's going to be this right here. So I'm going to get negative half pi r squared. That will give me negative 2 pi is equal to f of 2 minus 7. So f of 2 is going to equal negative 2 pi plus 7. So negative 2 pi plus 7 for that one. So I would like to figure out where my maximum, or my minimum value is happening. So let's just see. 7 and 3 definitely are not minimum values. I'd like to see which one of these would give me the smallest answer, I guess. Let's see here. Negative 2 pi would be, think of pi as about 3. So this would be like negative 6 plus 7. So that's going to be about 1. And this would be like negative 6 plus 10. That's going to be about 4. So if I'm looking for my absolute minimum value, this is going to be, whoops, negative 6 plus 7 is about 1, I think I said. So this at f of 2, that is where my absolute minimum occurs. So my minimum value is the y value. It's going to be negative 2 pi plus 7. So let's see, I get 2 points. If I considered x equals 2, so I decided that I would like to try to find something about 2. I decided it was one of my critical numbers. I got a point, and then if I gave my answer and I had justification, this table right here would be considered justification, so I got a point there. All right, part D, for each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. So f double prime, if I'm looking at f prime, I'm going to be looking at the slopes. So f double prime at negative 5, if I look at negative 5, it's right here. So I need to know the slope of that line. So to figure out the slope of that line, I'm going to take the point negative 6, 2, and the point negative 2, 0, and find the slope. So it's going to be 0 minus 2 over negative 2 minus negative 6. That gives me negative 2 over 4. That gives me a slope of negative 1/2. So that answer will be negative 1/2. And then the next one, f of double prime of 3, I notice the slope there, there's a sharp turn, so the derivative, it's not going to exist. So I will just say does not exist. I could probably technically say that it does not exist because there's a sharp turn there. However, I noticed on the scoring sheet that they did something a little different, so I would like to do that. If I'm looking, if a value exists, we should be able to find the limit from the left is equal to the limit from the right. So we should be able to find the limit as x approaches 3 from the left of the slope is going to equal the same thing, the limit as x approaches 3 from the right. And if I'm coming in from the left, the slope is going to equal 1, and the slope on the right is going to equal, actually that slope is 2. And then the slope from the right is equal to negative 1. So those two do not equal each other, so I could say the limit as x approaches 3 from the left does not equal the limit as x approaches 3 from the right. Whoops, points on here. We're going to get 1 point for that one. We'll get 1 point for this one with an explanation.